I thought I would just do a quick video of a fully assembled 100 horse US motor hollow shaft. Take you sort of through the components and then give you an exploded view of the components so we're all on the same page when we're talking about these. So again, this is 100 horsepower and they call it hollow shaft for a reason because the center rotor is hollow. Right? So that's where the pump shaft would come out of the floor of the plant and run up through the inside of the motor, and then there'd actually be a nut on top right here, and the shaft would come up and you would tighten the nut to lift the pump shaft off the bottom of the housing. And these run 30-40 feet down into the ground. So this here is the upper end bell, or you can call it an oil bath, you'll see in a minute. This will be where the stator is, and the windings are right behind this. And then the lower portion is your lower end bell. Up here, this of course is your ratchet assembly, and this is the hub where we actually have the brushes would ride right around this area here. So ratchet assembly for a reason. You can hear it ratcheting, and if it tries to reverse, so after you're pumping water and you turn the pump off, the water is going to want to force its way back, and this will stop it from turning backwards. So just to give you a little better idea, here is this upper end bell I'm talking about. So your bearing carrier would sit down in here with the bearing. So the bearing sits in this area and the carrier fits right around here, and the whole area here is filled with oil. This would be the lower end bell, and your lower bearing sits in there, and these tend to wear out, so we have to end up machining and sleeving these to tighten the bearing up. That's why a lot of these vertical motors, when they make noise, it's usually that lower end bell is the problem. Here is the center portion. These are where the windings are, and typically they're 4-pole 1800 RPM motors. So this is just another one assembled. And here is the typical rotor you'll see. You have threads on the end. That'd be the top end where you tighten the nut. Also the same thing over here is a smaller version. And again, they're hollow. Now I also have a video after this showing, I believe it was this rotor, standing up inside the end bell, and it'll give you a better idea of the clearance you have in this area down here. So your bearing sits here, right, and this is the clearance you have in video off. But I just wanted to show you all the pieces laid out as they are. Now, to break down the ratchet assembly, here it is right here. And what you'd have, I've got one here for you. You drop the balls down in here. They're typically just like a ball bearing. I think thought I had one for you. What do I? Yeah, I did. Sorry. Okay, here we go. So here's the ratchet assembly again, and the ball just fits down in the hole. Now it'll stop when it enters into this portion here. So your ratchet assembly sits on top of this base plate. When you're ratcheting around, the balls skip over the surface, and when it tries to run backwards, it just jams in here and it can't move. And the whole setup, all the balls are held in with a ring that fits over the top, covers the hole. Then your hub sits down in the center portion here. This is the typical truss bearing. There could be more than one. And this is the hub, or I guess you call it a bearing carrier. This is upside down right now because I want to show you. If you were to put a ceramic coating on these, the coating would run down the face and then right on this shoulder here, because this bearing will slide down until it meets here, and all the force is actually put right on this part right here. So if I turn this over, this is how it is in the motor, and then this bearing would sit up tight to here, and all of your about 5,000 pounds force can be pushed down in that area. So if you're coating it, you have to have the coating here, and you have to have it on that little ridge. And that coating is what stops the shaft current from creeping up from the rotor, coming out of the carrier, and then going through the wall of the bearing, and then out the other side of the bearing, which would cause all the balls in here to pit. And you get that fluting effect from the shaft current. So that sort of gives you an idea of the whole exploded view. And one other thing as well to talk about here is the hub. So we are typically machining from the bottom of the keyway to the bottom down here when we send it out to the machine shop. That's where the brushes are going to run. Now, two reasons for doing that. First of all, you have a clean surface for the brush to ride on. And secondly, these are not absolutely true. So if you didn't do a cut on it, you would see the brushes moving in and out like this slightly, maybe 10 thou. So I think we took 15 thou off the last one just to clean it up. You can actually see the brush moving if you don't true it up. And the machine shop is most likely going to reverse their chuck jaws and grab it on the inside here like this, because this is a true area. And you can see where they have factory balanced it by drilling it out right here. So that gives you, again, a good idea of what we have here and why we're putting the brushes on. And that's it.